Welcome to the Cycle World Podcast. I'm Mark Hoyer, editor-in-chief. I'm with Kevin Cameron, our technical editor. Thanks for joining us for another episode. This week's topic is Glenn Curtis, pioneer manufacturer of motorcycles, a man of great intensity, and suddenly quit motorcycles to do something else. After supposedly setting speed records, we'll talk about that maybe one of those, that V8 that he did was perhaps questionable. We have some supporting maths from a calibration engineer at a major manufacturer of motorcycles in America.
Yes.
We'll get to that. But Glenn Curtis is a hero for us, for all the things that he did and the application of his genius and technology and making things go. Got us up in the air. It's pretty cool. You should start this one, Kevin, as you normally do. Let's talk about the let's talk about the molecules of Glenn Curtis.
If I were going to write a book about Glenn Curtis, I would entitle it Rush Job. Because everything that man did was with an eye on the next project. And I wondered at first, as I looked at his early engines, why they all had the same basic cylinder. It was because he wasn't in this for engines. He wanted the power. He found he could get more power by adding more cylinders. First one, then two, then three. He built a triple. And then in the middle there somewhere, he built a V4, and then he built a V8, all to get more power. He wasn't interested in engines except as a means to an end, and so productive. In 1901, according to one story at any rate, he sent off to E.R. Thomas in Buffalo for a casting set to build a basic de Dion single-cylinder engine. Now, what's de Dion about it? It has an automatic inlet valve. The inlet valve is held closed by a light spring, and when the piston descends on its suction stroke, there's more pressure behind the valve than there is on the engine side. So the valve lifts off its seat. Air sneaks between the valve and its seat and into the cylinder. It doesn't fill it very well, but it works. And the de Dion and his mechanic, Georges Bouton, were able to operate theirs at up to 3,500 RPM. And soon, so was Curtis. And of course, the story was that, Curtis had been in the bicycle business. His dad was a harness maker, had a harness shop. So he'd got over that first hurdle. He knew that people made things. Just as people who plant a garden find out that food doesn't come in a package. So he put this first engine into a bicycle frame, and it didn't start, because he was using an improvised evaporator carburetor, basically an old shirt in a can, soaked with gasoline, with intake air going through it. What's the mixture control method? Good luck. So it fires. And the story is that it dragged him down the street toward Lake Keuka, and he managed to get it stopped. And instead of being frightened, he was delighted. And this is so often the case. He built bigger engines so he could go faster. He entered contests. He won races until he realized that continuing to make one cylinder bigger and bigger created problems. I'll have two cylinders. So in 1903, long before Harley Davidson did this, he added a second cylinder. And instead of using a fork and blade connecting rod arrangement, as Harley did, he put a lug on the big end of a the existing rod design, and he pivoted a link rod, which connected to the piston in the second cylinder. And when the second cylinder ran rich, because the fuel was already moving through the jet, when the second cylinder came on its intake stroke, he drilled a hole in that cylinder's intake pipe, bleed air. And of course, at this time, see, Curtis had this wonderful advantage over someone of similar disposition, namely John Britton, because when John Britton came on the scene, there were millions of people who understood internal combustion engines. When Curtis came on the scene, internal combustion engines were a big novelty. And airplanes had not yet flown. The Wright brothers would fly at Kitty Hawk in 1903, but they weren't telling anybody about it because they had plans to control the new field of aviation through their patents. Sort of like the Selden patent in the automobile business. Henry Ford just said, I'm going to get so big, this guy is just going to be blown away. And that's what happened. So, poor old Selden. So, at this point, he's got a product that he could sell. So, he starts manufacturing these things. His friend Charlie Kirkham from a place called Taggart's up the way, Charlie's dad had a rudimentary machine shop. So he and Charlie went to the machine shop to machine these raw castings to make engines. And as time passed, Charlie Kirkham took over more and more of the engine side because there was a lot going on. They built buildings. They had as many as 60 people working for them, making Curtis motorcycles, which today are a great rarity. I talked to a man who had been to a swap meet and had seen a Curtis V-twin, just the engine, $7,000. And he walked away shaking his head. And in his car going home, he realized, what a jackass. Get that 7,000 is nothing. But it was too late. He'd missed. So basically what these engines were was an aluminum crankcase with a roller main bearings, and the crankpin bearing was a bronze bushing in a split and bolted steel connecting rod. And oiling was by splash, as it was in so many early engines. Frederick Lanchester, around 1900, came up with the idea of pumped recirculating oil systems, but it took a while for them to catch on. And it also took a while for them to be needed. Fresh, cool, clean oil, lovely stuff. It's hard to have any wear when there's oil. And it's good. So they, the two men ran this motorcycle business. Kirkham taking care of engine manufacturing. Curtis trying to keep it all together. And around 1904, along come these airship fellows. They wanted engines for their airships. So Curtis provided them with V-twins, making 5 or 6 horsepower. And they could sort of putt along. If the wind were blowing, maybe you can't go upwind, but you could tack like a sailboat. And always this need for more power. So at a point, he takes 2 of his early twins, which have a 50-degree cylinder angle and puts them face to face to make a V4. The thing is still air cooled. The cylinder is a hardened iron casting with a side exhaust valve, and it has circumferential fins like a normal finned engine cylinder for a motorbike. The cylinder head is radially finned, and it has this threaded hole into which screws the intake valve cage, which has the intake valve, its seat, the intake port, the light spring, just about everything in that little screw-in guy. And as carburetors came on the market that you could just buy, no more tomato can or whatever it was. The historians argue this point. Was it a coffee can? And a sort of crude air-cooled V4 was made that gave double the power of the V-twin. And this whole process is going forward. And by now, Curtiss has 1 foot in the airship business and 1 foot in the motorcycle business. They're not going in the same direction. So he's doing a dance. And along comes Alexander Graham Bell and the Aerial Experiment Association. Some of these people are persuaded that an airplane can be made in the form of a multicellular box kite. And they built enormous ones, and they wrecked them. And Curtiss is looking at all this and thinking, who are these guys? Why don't they build an airplane? So they get busy building an airplane. And the third airplane to be built by the Aerial Experiment Association is Junebug. And by that time, he has the power. He's made more powerful engines. He flies the Junebug in 1908. It takes off and flies. The big problem for the Wright brothers is their patent calls for roll control by wing warping. And what the Curtiss airplane had was little subsidiary airfoils whose incidence could be varied. Today we call them ailerons, and they're part of the wing. And so it was going to come down to how are the lawyers going to treat this wording?
Yeah,
and how much?
that's
How
that
much?
in a nutshell. That's law. It's like arguing about words.
How much will we have to pay for them to come up with a definitive answer? And so another ball is added to Curtiss's juggling act, but he becomes a proficient aviator. He's able to fly. He's able to control the thing. He has the horsepower. It is not an improvised, semi-cooled thing. Although at one point, when he made his air-cooled V8, he said, it's the best little engine in the world for exactly 3 minutes. And that is the nub of the controversy, because before using the V8 to fly, he tests it in a motorbike. He goes down to Ormond Beach for the Scientific American Carnival of Speed. He has his lads at the factory run him up a completely improvised chassis. And this reminds me of some things that were built in the 1980s by major corporations. Oh, we finished the engine, and now we have $5 left to do the chassis. So they decide to drive the rear wheel with a shaft and a pair of exposed bevel gears running in bearings that are lubricated by drip. only when someone's holding an oil can over them and pressing the bottom of the oil can in. Boink, boink. So this is a cross your fingers kind of operation. What are the arrangements for timing? He's given 2 miles in which to accelerate. The measured mile, when he enters the measured mile, stopwatches are started, and people look at the crowd at the finish line through binoculars. When they see a flag waved, they stop the stopwatches. In this way, the celebrated 136 mile an hour one-way run, because the bevel gear arrangement in the universal joint made out of bent strap iron, flew to pieces and fortunately didn't tear off one of Mr. Curtis's legs. So they couldn't make a return run. It was always unofficial. But then here comes Wes Orloff at Harley-Davidson, who is in emissions and calibration and is a plain-speaking person.
Oh, Wes is great.
Very
Armor.
optimistic.
Yeah. Armor racer. I know him from Harley. I know him from I didn't race Arma with him, I did race Arma with him, but not against him. He's got some Buell products and some other vintage bikes with a friend of his in different classes. But avid racer, land speed stuff with Buell products, naked. And this is what kind of fired up his curiosity. Was he had done some land speed racing with a naked Buell and had some, they put a lot of work to get something like 144 miles an hour out of this naked Buell. And it got him thinking, because Curtis is also a hero of Wes's. He's also just, before we go on, he is the crew chief for James Rispoli in bagger racing. So he's passionate into performance and motorcycling and all that stuff.
He's in there. And Harley-Davidson are fortunate to have him, because so many big companies, when they replace some key person, the replacement comes from HR and may have to take an MIC course about motorcycles. What are they?
Well, it's just, it's cool, because Wes just, this was all triggered by Wes sending me an email and saying like, hey, I've been looking into this because it was so interesting. And it's just spreadsheets and calculations about frontal area and drag, coefficient of friction on the ground, and there is much controversy. So he brought all this to light. He did a lot of math, and he's like, I'm not, I'm trying to give this guy the benefit of the doubt, and I'm not seeing 136 here. And there was a lot at the time as well. There was weather. They were talking about the beach being too rough, and the weather came in, and finally on the second day, the waves came and smoothed the beach out so that the big potholes weren't there, and these rigid bikes weren't getting tossed to the sky, and that finally they could make the runs. And so there's just all kinds of,
and this is on 2.5-inch tires,
murky
2.5-inch section.
Yeah, totally. Yeah.
Wonderful. Anyway, so I get out my copy of Horner. It has an item on motorcycles, motorcycle frontal area, and so on. And I also have another book that shows a method. It's Victor Paget, actually, from years and years ago, and it shows a sitting up rider on squared paper, the outline, and a tucked in rider. And you count all the little squares, and you have your frontal area. This is done on a dark night with a point light source at a great distance, and a screen behind the object whose frontal area is to be measured. Anyway, what it comes down to is an effective frontal area, which means the actual frontal area multiplied times the coefficient of drag. That is, how much better is the shape you've made than a flat plate sawn from plywood.
Well, that's Yeah, the Caltech experiment with the XRTT and the so-called midget, the compact version of the XR. They said that the they said that the aerodynamics of a motorcycle were worse than a vertically placed piece of plywood.
Yes.
So great.
Yep. So, just taking this at its superficial level and combining it with Wes's stuff, what you come up with is that to go 136 miles an hour, neglecting rolling friction, is going to take 56 horsepower. So if the engine is rated, as the history books tell us, at somewhere between 36 and 40 horsepower, that's not 56 horsepower. So whose veracity shall we impugn? There were said to have been many people with stopwatches. When was the flag thrown? All these things we have no idea about. Who measured the mile and with what? Scientific American at that time was a popular mechanics type, popular do-it-yourself, what's happening in the world of manufacturing magazine. And they sponsored this Carnival of Speed from time to time. So you would think they would take a responsible, use a responsible method for measuring these speeds, but we're left with 36 horsepower is different from 56 horsepower, and 56 horsepower is probably an underestimate. But what happened, happened. We just can't put a number on it. Because at this point, Curtiss realized that the airship and airplane duty cycle was too tough for air cooling. It wasn't going to work. So he looked around for someone who could help, and he found Sandor Pfitzner, an immigrant to the U.S. from Hungary, who was working for Buick. Pfitzner was evidently interested in aviation, and that was probably part of why he could be hired away. He came to Hammondsport, New York, where Curtiss's plant was, and he set about water jacketing the cylinders for future aero engines and generally shaping them up, because he was familiar with what was going on in the wider world, such things as pumped recirculating oil systems. And this is how Curtiss, mind you, Pfitzner is hired early in, well, we don't know, but he had less than a year to prepare a water-cooled V8 for the great French air expo at what looks like Reims. And Curtiss packs up this airplane. You know, it's a bundle of sticks and some rolls of yard goods and some wire. But you have to know how it goes together.
Well, I mean, when you get down to it, we've been flying lawn chairs for 125 years.
Yes, indeed. So he gets over there. He rigs his airplane. He flies, and he wins the grand prize. It is unbelievable, because to take the thing all apart, put it on a ship, arrive, keep calm. The French people writing about him said that his calm was admirable. And we see these photographs of him in which he looks so intense that you could imagine him imploding like a black hole. He's on it. He's thinking, trying to think of everything. And he keeps it together. There are the photographs of him in France with the big radiator directly behind him and the engine behind that. So we know that it was a water-cooled V8 making basically 90 horsepower, some say 100. He had power, which these other characters didn't. Louis Blériot, the first man to fly the English Channel, Henry Farman, all the greats of European aviation were there. And the French took aviation they loved it. They embraced it so hard. It was delightful to them. And at one point, Curtis said that as he was flying the course, he could look down and see the litter of the crashed airplanes of many of the competitors on the course. Onlookers said that his turns around the pylons at the end defining the course were sharp. He'd learned to fly, and he was doing it. So this was August. In September, he was at Brescia in Italy, where he wowed him again. He could take his airplane wherever people wanted it, and he could make it fly.
That's amazing. He was like a 30-year-old when he's doing this. And
yes, he was 30 years. He was born in 1878. So in 1908, he was 30 years old. Yeah, when he flew.
And this is the liquid cooled. This is the OX5. They called it, right?
Well, it didn't become OX5 for a while, but it was a good beginning.
Like a prototype
for OX5, yeah.
And so we're talking about a guy flying a plane, designing a plane, coming up with some version of ailerons. And it's not just figuring out like, oh, if we do ailerons, we can make the plane turn. It's what are my means of controls? What are the ratios of the bell cranks?
Yeah.
How do I have enough force, human force, to move the controls?
What's enough? What's too much?
What's enough? What's too much? And then where are the ailerons? How much surface does the aileron have? What do you need for authority? We would call it rudder authority or elevator authority. Enough authority, but not too much authority. I mean, there's no manual, right? Because it's uninvented, and there's no learning to fly book either. It's just like, well, okay, let's try this.
It was very much cut and try, because you can imagine him landing and saying, I can control it, but it's not easy. Let's make these things bigger. Well, we find out that at Lockheed's Skunk Works, this story was told to me by a man who was in the thermo team designing that airplane, SR-71. He said they looked at the data from the strain gauges in the aircraft structure, and they could see that some of the wing spars were close to yield. And so he said the team got together and they said, how much do you think we should kick the leading edge downward? And somebody said, well, let's start at 6 degrees. Yeah, sounds good. Okay. And so it's basically the same process. They didn't go to a computer. They didn't create a math model. They didn't wind tunnel endlessly. They needed the answer now. And this is what aviation and motor racing teach us, that there are times when time is so much more valuable than money, if you have the money.
Yeah, that's a good way of putting it. What's that saying about if I had If I had some bread, I'd make a sandwich. If I had some meat.
Yeah.
So, what's remarkable to me is we're talking about, Glenn Curtis, 1908, flying his V8 and knocking it down and having guy wires and all that, and just kind of building up his thing and figuring out how to get his ratios. And the SR-71, which you just brought up, his first flight was like 64.
Yeah.
So it's like in 50 years,
Sure.
we're flying across the country in 45 minutes. Like we're barely getting off the ground, and just 55 years later or whatever, we're
I think in France he went 42 miles an hour. And there were like 50,000 people there.
Which must have been wonderful. I mean, imagine that. I mean, flying feels so good. Like just going up in anything, light plane, Cessna 172, 152, the Chevette of the skies. And,
Yes, it is.
and just a slow, 152s, you buy them to get time, or they're nice little knocking around airplanes, but, you don't have a rate of climb so much as you circle around. You kind of reduce the gear ratio of the sky, so to speak, to get up in the air. Not high performance, and yet it feels so good. It's like riding an XS650 like that behind me. That's a kind of a tired old XS650, and it was a good motorcycle for 1972. Had some robust bottom end and good running, a little bit of vibration, but it's alive. But you're not getting anywhere. You're not getting anywhere really fast, or
Yep.
and yet you click it into fifth gear and you're going 57 miles per hour. And if you go over 60, it vibrates a little more. So do I want to go that fast or not? But it still feels good. It still feels good. And
the Sportster question.
Yeah. Going 42 in an airplane in 1908 would be, imagine what's the analogous? There. Yeah. The analogous experience. I mean, to be in the sky. I don't know. Yes. It just flying feels good the way that motorcycling does, in a way that automobiles tend not to, because of the dimensions of movement.
When he was finished up at Brescia in Italy, these people came over to him and they said, our poet, Gabriele D'Annunzio, would like to go for a ride in your airplane. He wants very much to do so, and we want him to. Okay.
Yeah, double the load, by the way. But
so he takes him up and flies him around, and of course he has wonderful things to say when he returns to Earth, as so many did after their first flights, because the terrible thing is that the American space program shot those people up into orbit. Then they landed them on the moon. And after that, nobody cared, because they had Star Trek to hold their attention. Whereas space flight today, who watches that?
My son.
It became routine.
It is routine. Amazingly routine, isn't it?
Now we find that the 777X is supposed to get this 134-inch fan engine. That's a big wheel. The landing gear must be something else. Anyway, Curtis, of course, just completely lost interest in the motorcycle business. He did get as far as making triple with 50 degrees between each of the pairs, and
a W3, right?
A W3.
W3.
And supposedly it made 10 horsepower, and still the same basic cylinders, a circumferentially finned cylinder casting and a radially finned head.
Well, Jim Fueling in the sort of early mid 2000s had the Fueling W3, where he took a Harley and threw a third cylinder on it, and I believe it was a master rod with nubs on it for slave rods. I rode that quite a bit. I got to test that bike, and Yeah, you just add, you add 50% more power. There's another one tacked on there, and his
Yeah.
his motor, Jim Fueling could really make an engine work, and he was a great guy to talk to. And we talked about combustion chambers on two strokes, and he showed me a cylinder head that he was running on a CR 500 that had essentially the entire diameter of the piston was squish, and then there was a small diameter that was shaped like a rocket nozzle with probably a 1/4 inch radius or something. And when I say small diameter, I mean, like centimeter, maybe 15 millimeters,
Yep.
and a little kernel where the spark plug was. So the place the combustion was happening was the size of smaller than a walnut.
Yeah.
And the whole cylinder was squishing everything into that little kernel, and they were lighting the fuse, with the spark in this very high pressure nozzle blast onto the piston, and we're having some success with that.
Good rate of pressure rise.
In any case, the W3 was awesome. It would burn the back tire. They just sent me out in Ventura where his shop was. It was just an industrial unit. Had to walk around the 4360 engine in a can, pickled, that he had, which is, Kevin's a fellow 4360. What do you say? You're in recovery from 4360s?
Yes, I am.
Yeah. Made his donations. I think he gave one to the Air Force out in Ohio, or the students, the high school.
Yeah, I think the students had it, and now some Navy unit down in Rhode Island, I think they're running a C-119, and the two of the engines I had were C-119, and so now they have a lot of parts.
Oh, nice.
Yeah.
Anyway, the fueling bike was a lot of fun, but as it is with, I want to say, almost everybody who makes a big displacement, long stroke, something less than 4 cylinders. I've seen it with 3 and a lot with twins. Breather issues. It always seems to happen. Maybe breathers have finally been figured out, but engine breathing has been like an ongoing pain in the ass. And sure enough, I was out there just hammering that bike, and I had to get out my Nokia flip phone because the thing was puking oil. And I thought, oh no, I've ruined this motorcycle. And so I called the shop, and I got not Jim, but I got the mechanic and tech dude who was helping me. He's like, oh no, good man. It means you're riding it hard. So that's my job. Ride it hard, see what happens. But yeah, anyway, W3. Yet another tangent, Kevin.
So in 1911, a fellow named Eli landed and took off from a platform built on the stern of the USS Pennsylvania.
Amazing.
A Navy ship.
I mean, we're building a deck, folks. Just like,
yeah. And
place to arrange our lawn chairs.
This was at San Diego. So that was the kernel that led to the aircraft carrier. Because the terrible problem for the fleet was, what if they attack us with airplanes? We need airplanes of our own to stop them.
Yeah, that's like, what is that? You mentioned the immune system. That was off camera. That was autoimmune, but this is like, what do you call that? That's an active immune system that goes outside.
It sure is.
It goes out outside the body of the ship to attack the attackers before they attack.
That's the thing. And soon naval aviation was launched. And I think poor old Thomas Selfridge was the first person to be killed he was an Army man, flying an Army aircraft. And he had been one of the early experimenters. He was one of those people that said, yeah, I'll do it. Yeah, count me in. And that's always the problem when they count you in, is that you might be on the unlucky flight, and he was. But meanwhile, Charlie Kirkham is developing engines. I think he came back and worked for Curtiss from 1915. And Curtiss wasn't concerned about engine details anymore, but the Curtiss well, really, K-12, K for Kirkham, you might say, was a V12 engine. They had made V12s earlier, but this was quite a modern engine. And then they made the D12, A, B, C, D. And with that, they were able to win the Schneider Cup seaplane race in Europe, taking the first two places. And that V12 so impressed the British Air Ministry, mind you, designed by Charlie Kirkham, based on experience that he gained working with Curtiss. And also, he got his introduction to engineering by mail. He took a correspondence course in engineering while he was down with diphtheria. And so here's Charlie Kirkham from Taggart's, New York. His D12 is ordered in small quantity by the British Air Ministry, and they shipped these things to British aircraft engine manufacturers and said, think you could come up with something like this? And the one they sent to Rolls resulted in the Kestrel and then the Great Merlin, the V-12 that was in the Hurricanes and Spitfires that defended Britain in the Battle of Britain. So it's grand, I think, to be able to trace these important elements in aviation, the aircraft carrier, the Merlin, the idea of a V-12, having the facilities and the drive to produce, to dare to try to make a V-12, all goes back to Curtiss. And when World War I was raging, the British Navy, the Royal Navy, sent officers to his premises because he wanted to bid on their requirement for a coastal patrol aircraft that could land on water. And they came, and what did they see? A huge shed-like structure with people building airplanes on the floor in a crowded chaos. And at one end of the building was a huge set of drawings which were being amended hour by hour. Well, we can't, that's impossible to make. Lots of drawings have things on them that are impossible to make, and the people in the machine shop fix it, or the people in the foundry fix it.
Oh, long history of the foundry folks fixing things just on the fly.
Yeah.
Because they know what's going on with the materials. I mean, it happens now. Pattern makers,
Yep.
they're like, oh no, what are they thinking? I talked years ago, I talked to Pierre Terblanche when he was working at Ducati. So he was in the heart of the Motor Valley in Bologna, and they were working with the casting people and all that. And I said, oh, I've got this Thames van, English Ford van, might become a drinking thing here, but because they bring it up. But the Thames van, I could get a cylinder head. I said, yeah, the cylinder head is tragic on this thing, Pierre. It's got 2 intake ports. We were talking about vintage refrigerators, and I showed him a picture of the Thames, and he was fascinated by this English Ford van that all the racers used in the late 50s. It had an overhead valve engine, but a terrible cylinder head. And he said, oh yeah, we can get you one made. And it was going to cost like $10,000. But he said, yeah, we'll just call the guys at the foundry and just ship the head over, and they'll pick up where all the bolt holes are and the water jackets, and you don't have to do anything. The combustion chambers, they'll just do what they know works.
They'll fix it.
Yeah. Fix it. $10,000, man. That's all it took.
Yeah.
I kind of wish I had, because it was a unique opportunity. But again, if I had some bread, I'd make a sandwich. If I had some meat. So.
Well, these Royal Navy officers must have liked it because they could see that this was a workable process. They weren't just making something, they were documenting it as they went along so that when they built the next one, that the latest improvements would be included in it. but it wasn't being done by the classic process of there's a drawing office up in space somewhere occupied by people who know how to speak Latin and Greek and the poetry. And down here in the foundations are machinists who are covered with cutting oil, and they have chips sticking to their cheeks and foreheads. And somehow drawings connect these two regions, heaven and hell, in a creative enterprise. But
Yeah, well, Rolls Royce was like that in the early days. Every car was different. It evolved. Every time they finished something, they would just like, oh, what if we do this? And they just evolved. Even the small horsepower ones, like the 2025s of the, say 1930 to 37, 40, somewhere around there. I mean, small horsepower ones were not, this was not, they were sort of aristocratic, but these were for folks who were kind of like almost there, but not there. And they were going to drive their own cars. They didn't have chauffeurs doing all that.
These were Buicks.
These were, as we would say, Newport Beach, the Mercedes. Well, actually, the McLaren is almost the Newport Chevy. That's what we used to call the Mercedes-Benz down in Newport Beach was Newport Chevys. But they were just iterating. And if you get a 2025 from like 1935, it's much different from one that's in 37 in many details. And there are not no interchangeable parts, but very little is necessarily like bolted on. So anyways,
here's the thing about Curtiss is not only was he an aviation pioneer, but he productionized the aircraft industry. No one else did that. He did that. And they had to come up with a system by which they could build these coastal command reconnaissance aircraft. They shipped a bunch of them to England, and it was a mad scramble. That's hence the title of the non-existent book, Rush Job. And Curtiss later said, we burned the candle everywhere we could light it, and now I'm so burned out, I'm finished. So what did he do? He retired to Florida and conducted business by telephone to the factory.
That's what Dick O'Brien did.
Yeah, he dabbled in real estate such that he was able to get together sufficient territory to make Miami Airport. He did a lot of hunting and fishing. He did not sit on the porch looking at the sunset with a warm rug over his knees. And I think he died of complications of appendicitis or something, but he was 52 years old.
Mm-hmm.
And he couldn't stop. He couldn't stop himself. And so these frenetic individuals, he looked at engines because they were the way for him to make motorcycles. When he raced motorcycles, he needed more power, so he added more cylinders. He wasn't interested in flow benches, dynamometers, tedious detail improvements. Just put more cylinders on. We've got something that works.
It's such a fundamental personality type thing.
Yeah.
Because there are people that all of that is irresistible. And that's where you get somebody like Ricardo, who didn't like math. He liked to try things. He was a very good communicator, great writer, and, refined, codified. He was good at marketing too. So, he figured out flathead squish and ticked the box like, hey, I'm patenting this thing. And the way he sold Ricardo heads to everybody.
Harley Davidson.
Made a fortune.
Yep.
I mean, you'd think fueling is kind of the same way in the sense of, all his work with exhaust ports, make them as small as possible with the least amount of surface area.
And move them away so that the intake ports could become larger.
Yeah.
Well, I had some conversation with him, both face to face and over the phone.
Jim Fueling?
Jim Fueling. And
Yeah.
I've also talked to people who've had dealings with him, and they said, well, to be kind, let's say that if you go to lunch with Jim and you both make notes on the back of an envelope together, he leaves with the envelope. But he was very generous to me when I was a first-time speaker, only time in my case, at the Superflow conference in Colorado Springs. And he helped me get mic'd up. And later he said, I'm going to send you a kit of books that you will find interesting. And there was a history of surfing in there. And there was also something about an obscure two-stroke that I'd read about in Mechanics Illustrated in the 1950s. And all kinds of fascinating stuff. So he was a person who filled himself with details and had them all at his fingertips. So,
Well, in addition to that 4360 in the backyard of his shop, a 28 cylinder radial, folks, that's big as a house. Big as a car anyways. And he had one of those engines, at least one in the back in a can, with the big hooks so you could move it around. And then he also had at least one tank. He had some military vehicles.
Yes, he did have. Yeah, he was interested in that.
He had a tank, man. He just was, whatever, transportation enthusiast.
Eventually, before he died, Curtis was taken for a ride in an airliner powered by his company's later piston engines. And he obviously survived his encounter with the Wright brothers. They continued to develop their engines, but not with the intensity and results that Curtis did. And of course, the irony of the whole thing is that in 1929, Curtis Wright Corporation was formed, bringing together both aviation entities to build airplanes and engines. And they finished up World War II in a very strong cash position and never really accomplished anything again. Because although they built jet engines and they constantly tried to interest buyers in a civilianized C-46, the public didn't want to walk uphill to get to their seat in an airliner anymore. As far as they were concerned, if you have to walk uphill, that's some pre-war stuff right there.
Antiques, man, tail draggers. Yep. What do you even? That's all I want is a tail dragger.
And of course, that is wonderful, that moment when the tail lifts. And it seems to happen almost at once. You know, the airplane's moving, and then the next moment you see the tail is up, and it stays like that for quite a while. And then finally, the air wafts it away.
Well, I flew in a B-17 out of Knoxville with Peter Egan many, many years ago now. And that was remarkable because you have all that, you have all the vibration of all three wheels on the ground, four engines getting the wah, 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 because they're basically the same RPM, but not quite. So you get these really interesting waveforms that make it sound interesting. The plane's shaking and shaking, and the tail comes off and it shakes a little bit less. And then you just get an inch off the ground and it's serenity. I mean, it's still loud and everything.
Yeah.
But then you're on this cushion of air and there's no more of that wheelie vibration. And it's like, oh, and there was no top turret or anything on it. And I would call it the sunroof. So there's a big open area in the top of the fuselage and you can stick your face out it. Like you could actually, if you're tall enough, get your head to stick out the top of this plane while it was flying. And it was one of these beautiful, misty Tennessee days where it was sunshiny, but there was a lot of humidity and there's green rolling hills and it was out of this world. I want to talk about Curtis because we made the SR-71, saying like, oh, 1964, in 1908, he was going 43 miles an hour. In 1964, we were doing, many thousands of miles per hour.
Yeah.
And, but I don't want to discount the progress that he himself made, because it was 42 horsepower or 42 miles an hour, maybe 50 to 100 horsepower. And then you were talking about the Curtis D12. That was 485 horsepower.
Unsupercharged.
Unsupercharged in 1921.
Yeah.
Like, no messing around. They just are going. And that was his seaplane that went 177 miles an hour.
Yep.
And then that's the motor that the British Air Ministry ordered and led to all the wonder and
Sent
amazing.
them around to manufacturers as a suggestion. I like it.
I love inspiration.
Never mind that it's foreign. Have a look. You might learn something from Charlie Kirkham.
I was always fascinated with the idea that the Merlin cylinders are up, are they not? Right.
Yeah.
The cranks.
Yeah. Whereas the German engines were inverted. You mean?
Yeah, I mean, in the Ranger 6, which was an American inline 6, the cylinders all faced down in a line of 6, and they put the crank up to get prop clearance. And
the pilots are always saying, it would be better if I could see the runway, but I can't. So I carry this 6-inch piece of rubber foam and just tuck it under there when I'm landing, so I can see out. And that's why you will see on F6F, which has an R2800 radial up front, that the fuselage slopes upward to where the pilot is located, so that he has some chance. Oh yeah, that's the carrier there. And it was worse with the F4F Corsair, which for weight and balance had the 2800 sort of extended out front, and it was just this monstrous thing in front of you. You couldn't see a thing. And it was official policy in the U.S. services, no carrier operations. Meanwhile, the British developed a circular approach to the carrier, so that as you're turning, you can look across on a chord of your circle and see the carrier. And they developed methods for a circular approach, and that was adopted for that aircraft in the U.S. Navy. So it was able to make its contribution.
To do quite a lot.
Yes, indeed. Now, the Curtiss side produced liquid-cooled engines because of Glenn Curtiss's best little engine in the world for exactly 3 minutes. But the U.S. Navy fostered the development of air-cooled engines because they felt that the lightweight and simplicity of an air-cooled would be more compatible with over-water operation. So air-cooled radials were developed intensively from the mid-20s. Lindbergh flew to Orly, flew across the Atlantic Ocean and landed at Orly Airport near Paris in 1927 with a J5, I think, 9-cylinder air-cooled radial. So such progress was made in the cooling of air-cooled cylinders by making all the air that came into the nacelle go through the fin space. Eventually, the Navy said, we're not buying any more liquid-cooled ever. Half of our problems in overwater flying have to do with cooling system problems, so forget that. So it's horses for courses, yeah.
Well, why do you like a 50s motorcycle? Because it doesn't have brake fluid. So you don't have to deal with seized hydraulics when it's been sitting forever. You just have cables and drum.
Ruined paint.
ruined paint. You don't have to worry about. There's no brake fluid. Brake fluid smells. I hate it. I hate how it feels, and it strips paint beautifully. So that's why 50s motorcycles are cool. You don't have to mess with that, and then you don't have any of these like water pump seals or hoses or radiators or any of that hoo-ha either. So
I
there you go.
remember leaping out of my bed and going outdoors to my van, in which I had just arrived from Florida pre-Daytona testing, to let the water out of my race bike engines. Because in a dream, evidently, some computations were going on in my head that said, "You idiot, your bikes are freezing. Fix it." So
You know what they say?
there
If
it
you're
is.
cold, they're cold, Kevin.
Yeah, you got it.
Yeah,
So
and
that,
you wouldn't have a lot of coolant in the race bike. They don't like that at all at the track. It's too slippery.
yeah. Well, that's
Come.
why they have those trays under their bikes that collect oil from blowups
Oh
and
yeah,
liquid from anything else.
I've been admiring all these Armour race bikes that I should wish to copy in some form. And I was looking at one guy's XS 650, and I thought, damn, he's got a huge sump on that. But then I realized, because he has a very compact tray that's underneath
Yeah.
the engine. They do put drop sumps on these. There's a plate you can get, not plate, but a cast piece that drops the sump plate where the filter is and the pickup, and it lowers the oil level below the crank, because as it is stock, the crank's spinning in oil. Like, it's actually in it. It's pretty, for sustained high RPM operation, not ideal. Lots of heat. And so when you drop the oil level below the cranks, you're going to pick up several horsepower on the dyno, and you're also going to reduce the operating temperature of your engine.
Yep. In the early days of single cylinder racing in England between the wars, one of the first things that would happen when one of the wizards of tune would be hired by a company that normally didn't do any racing, such as New Hudson, is that the wizard would reduce the diameter of the flywheels so as to reduce their ability to trap oil between the crank and the close-fitting crankcase, which you could see if you had an oil temperature gauge, because the engine is transmitting a lot of power into the oil that is now not going to the rear wheel. And that's why longtime Harley racing manager Dick O'Brien said, when it starts to wet sump, you can just see it. He said, especially Daytona. It's like a big invisible hand came down and just stopped it.
I had a 1971 Triumph TR6 car with a non-overdrive, and I want to say the rear axle ratio was like 3.7 to 1. And on the freeway, if I went 3,500 RPM, which was probably about 70, everything would be fine. And this is a pretty knackered power plant. Don't get me wrong. This is not perfect condition and perfect combustion chambers. But if I whizzed that up to $4,000 and I really wanted to get somewhere, $4,000, and I'm going 80, the water temperature would go up and the oil pressure would go down, because it didn't like it. It didn't like all that worrying about, and it just made everything hot, because they call it windage, but wouldn't we call it oil? It's oilage. It's the oil getting smacked around like that. The oil's, it's got to drain off everything. That's why sometimes inside crankcases, they'll put screens to grab the oil and let it drain down the side of the crankcase rather than getting smacked around on all the flinging parts.
This brings us back to Glenn Curtis.
Oh, good.
Because the OX5 had these problems in high degree. And what they came up with was later also applied to the R4360 28-cylinder radial, namely perforated steel sheet. Because what it does is it allows the oil to pass through, but it takes a lot of its energy, so that instead of hitting the walls of the crankcase and bouncing off back onto the crankshaft, it obediently clings to the walls and trickles down to the sump like a good little quart of oil. So there's the wonderful story about Luke Hobbs, who was in charge of the 4360 development program, actually the whole design process. He's sitting in his august office. He gets a phone call from the dyno room, and one of the men says to him, "I think we've got it, sir." "Well, get up here. I want to hear all about it." So the guy standing outside of his door with oil dripping off of his elbows, holding these parts. The problem was this is a 2-speed supercharger engine, and the 2 speeds were achieved by drain and fill fluid couplings. Clutches. So what was happening was that when the speed change happened, one of the pairs of fluid couplings would throw all its oil out. And it was causing a loss of 300 horsepower. So
Remarkable.
yeah. So what they did was they got a crude die made, or they did it piecemeal by welding, and they came up with perforated metal that could be fitted into the fluid coupling case with 1-inch spacers to the walls, so that when that shower of that explosion of oil took place, that the screen slowed it down enough that it could just trickle down the sides of the cavity to the scavenge pump. So OX5 was the engine developed from the water-cooled V8 that Curtiss used in France and Italy to win those flying meets. And the OX5 was, I think there were like 12,000 of them produced. And my mother rode in a JN4, a Jenny, Curtiss Jenny aircraft, powered by an OX5, when her indulgent dad said, "You want to go up in that crate?" "You bet."
Amazing.
Yeah.
Yeah, of course we do. Well, of course. Yes. Well, excellent. Yeah, I was thinking of all this windage, oilage stuff. Also seeing crank scrapers that some of the V8 guys have used, where you have a piece of sheet metal that you kind of bolt between the pan and the bottom of the block that has a cutout that's, very closely arranged to the edges of the crankshaft, meant to keep the oil from coming back up into the area of turbulence.
Well, a viscometer is a pair of concentric cylinders. One of them is fixed, and its torque is measured, and the space between them is filled with the oil whose viscosity is to be measured, and the one cylinder is rotated. And that's basically what a crankshaft in a close-fitting crankcase is, a gigantic viscometer.
Allow me to say Velocet, people. I have the large I have the large crank wheels in my 54 Velocet. So they have the big ones and the small ones, and I have the big ones. And what the big ones do is pump oil in to the primary case, because there's no seal on the drive bearing. And so the dynamics of that engine, even with you drilling a hole under the magneto and putting a breather in that it did not have, that's basically the place we all put the breather in, put a brass fitting and run it up to a bottle or back to the oil tank. And so then I thought, well, I don't want oil going into my primary drive. I'll get my buddy to machine my crankcases and put a seal on the drive side. We'll put a lip seal on the drive side. That'll solve it. And you know what that did? That pushed a lot of oil out the breather that never happened before. It's got to go somewhere. Still doing it. And then the small ones will actually remove oil from the primary if it's in there. They kind of make more of a vacuum, which is, yeah. Anyway, we could go on. I could talk about Jim Comstock and his reed breather that he makes for Norton Commandos that is now being manufactured by NYC Norton, New York City Norton, Kenny Cummings, also an armor racer. And it's a big screw-in reed breather, beautifully done, 6 bolts radially holding it. And then the pipe goes off of the bottom of the engine. You take out this huge plug, you screw in that reed breather, and you run it back. And when you start a sumped Norton, a wet sumped Norton, because they're dry sump, meaning the oil stays in the tank, and there's a scavenge pump that pumps it back to the tank to be sent down the pressure line. If your Norton sumps and you kickstart this thing Normally you'd like, oh, let me drain this out. And I'm like, I'm not draining this thing out every time it sumps. You kickstart it, and the reed breather will clear the crankcase faster than the scavenge pump.
Yeah.
It was remarkable. It was
Yeah.
great. And all the problems went away. Not problems, but it used to weep a little oil here and there. And that reed breather was working. We had negative pressure in the crankcase because it was always cutting it off. It was awesome.
I'm not the only person who's looked inside of one of the high performance 600cc fours that were the backbone of beginner racing in the US for such a long time. You look into a gearbox and you say, well, the gearbox is way up here and the oil pump's way down there. There's a lot of space here. Wonder what we could do with that. It turns out that one of the race teams, of course, this is just a rumor, it might never have happened. One of the race teams, guy comes in and he says, I got a vacuum pump here. It fits in that space. We could evacuate the crankcase. Oilage, windage, zero. Let's do it.
Well,
Of course.
there's, the top fuel drag motors, they talk about having 7 pumps working on the engines, vacuum pumps.
Yeah. Yeah.
And also that the fuel going into the cylinder is nearly a solid column.
Yes.
It's amazing. Anyway, surely this is related to Curtis.
Well, everything's related to Curtis because there he was at the beginning.
Yeah.
The roots of the plant.
Well, thanks for listening, folks. That's another one of the books. Appreciate you being here and sharing the time with us. Share the podcast with your friends if you think they would like it. And again, podcast brought to you by Octane. Click that link in the description. For real, click it. It makes a difference for us. We appreciate your comments, and we appreciate Wes Orloff for triggering this podcast and using his considerable skill to math out what may have happened on that day at the beach back so long ago.
Yes.
Just remarkable. And Kevin has avowed to write us up a story that would, cover all this stuff.
You bet.
Using Wes's research. So we'll get that posted here and share that with you in the future. Thank you for listening, and we'll catch you next time.